Hi friends, today I'm going to show you how to make a simple tracker using a gimbal. Is a machine vision camera called ProSilica following IEEE 1394 and a laptop. The gimbal is having a specification of 0.01 degrees. It's the minimum movement. It's powered by a 12-volt battery here. The camera in turn is also powered by a 12-volt power supply. The gimbal is following serial communication which is connected to my laptop, and this is the firewire socket for the camera, which is this wire going to the camera and connecting it. So this is my present setup. For tracking as the light source, I am using a torch as a light source, and the platform which I have used is VC++ 2008 Express Edition. The code is written in C++, and I have used a open source library called open source image processing library called OpenCV. Well, you can see this is my light source. Well, the algorithm for tracking is very simple. It's like I have a 300 cross 300 window of track. This is the center. The bright source of light appears here. uh, this is the offset. I mark it with a rectangular box. I found out the center of that rectangle. This is the offset x, this is the offset y. This is converted into elevation degrees, this is converted into azimuth degrees of the gimbal. Both are then fed to the gimbal. According to this and this, the gimbal rotates. You can see the gimbal, it can rotate. This is the elevation, it can rotate, and this is the azimuth. According to this E and elevation and azimuth, it rotates and moves the camera in that direction. uh, when the camera after the camera is moved, this bright light again comes to the center. When it comes to the center, again the camera searches whether where is the next position of the bright light or the blob, and again calculating the offset with respect to the center and adding it with the current gimbal position, it moves the camera as if it like takes the blob always at the center of the image. It tries to keep the blob always at the center of the image, and doing this it follows a run around condition. Well, the let's start doing it. Oh, serial port is open. Well, you can see initially this is the command prompt. It will show the instantaneous x and y of the gimbal, azimuth and elevation. Here the live track window is there. This is my live track window. It is initially 0 because the dark because the camera is set to minimum aperture. So now let's start our tracking and see what we get. So see, when as soon as light source comes, this is like it always tries to keep the blob at the center. It moves the camera in such a way that the bright source always appears at the center of my track window. You can see I have marked it with a rectangular red box, and I am always calculating the center of that. And here you can see the azimuth and the elevation is always instantaneously updated. This azimuth and elevation are of the gimbal. So on a practical side, if we see, this is the movement. It moves in elevation very efficiently. It can move in elevation, it can move in downwards also very efficiently. You can see it's going up easily, and it's quite fast also. Well, it can move in azimuth also. Here you can see it's moving in azimuth. It's moving in azimuth. and now it can move in azimuth as well as elevation simultaneously. There you can see it's going down. It's moving in azimuth as well as in elevation simultaneously. See, it's moving in azimuth as well as in elevation. Well, one of the problems of the system is a track loss. Track loss is like, suppose the source of the light moves very fast with respect to the gimbal and goes out of the field of view of the camera. Then the camera does not know where to go. Presently, I have not put any intelligence into it, like a sort of a predictor to predict what were the possible positions it may be in case of a track loss. Right, as of now it's a very simple tracking. It's just following the light source. It doesn't as such know where to go if there is a track loss like this. I mean, the source moves very fast with respect to the gimbal, so that is, it's one of its present drawbacks, which can be like overcome by incorporating a predictor algorithm. For this application, I have used a open source image processing library called the OpenCV. It's very efficient, that library. It gives you the ease of reading an image and showing an image, and it also provides you many useful libraries with which you can build many uh, applications, especially real-time applications, because like OpenCV codes are very optimized and optimized for real-time computer vision applications only. So this is one of the applications you can see. It's a simple light source tracker, bright light source tracker, using a machine vision camera mounted on a gimbal and a laptop. So this is the power of OpenCV, with which you can utilize to make a simple tracking application like this. Thank you.